So we've talked about two domains already. We've talked about um, the user domain. We've talked about the workstation domain. I think we talked about the LAN domain also. So we did three of them. And now we're doing to LAN to WAN domain. So that's the objective, is to cover all of these domains and help you to understand what we have to protect in each domain. Remember, the reason they break them up into two domains is because it's really too much to all audit at the same time. So this would be a separate audit than the end user, than the workstation audit. They could put the audits together if they wanted to. It depends on how big it is. Remember, we're not in this class to become auditors, but we want to be able to do assessments of our own equipment before the auditors come in. So that's why we need to know this stuff. It's not necessarily so you can become a computer auditor later on. You can if you want. It's to get you in the mindset of what you have to do before an auditor comes in, an external auditor comes in and looks at your IT infrastructure. We're going to talk about law compliance with law requirements in the LAN to WAN domain. Remember, our LAN to WAN, that's just a fancy term for our border, right? This is going to be the router that goes to the internet, where we have like a firewall or the edge of our network. We're going to talk about devices and access controls we could use to maximize our CIA triad. We're going to talk about different policies you can put in place, procedures and guidelines, best practices. We're going to talk about vulnerability management, how to test this domain, and best practices. Best practices is like the best part of all of these chapters because it gives you ideas of what you should be doing. Tells you exactly what you should be doing. So the reason we need to audit this domain, the drivers, the compliance, that drives this audit in this domain, is that we have to keep information secure as it's in flight, as it crosses the networks, it's completely different keeping data secure when it's in flight than it is when it's at rest. When it's at rest, we have disk encryption, right? This is keeping stuff secure while it's being transmitted. A little bit different stuff. It's really important when we're trying to provide privacy and confidentiality to our customers. And the thing that should pop into your mind when I start talking about this network stuff is the PCI DSS. Because we did our research, we saw that like the first thing you have to have, like the six principles and the 12 things you got to do, was a firewall. So this should, trigger in your head PCI DSS when we look at, talking about the network and data in transit. Remember, we want to protect data privacy. That would be HIPAA, right? The privacy about their health records. We also want to not only make sure that their information is confidential, that's the C in the CIA triad. We also want to make sure that our systems are available. That's the A in the CIA triad. So we're going to look at the ways to set up our ISP connection to ensure that we have connectivity. We're going to talk about the security policy and then the controls that we're going to use. Again, we're in the LAN to WAN domain. We've covered the user domain, the workstation domain, the LAN domain, and then we're here. We're going to finish out this last month talking about these last three domains over here. Remote access, WAN, and then the application domain, where we start talking about like web applications. So Most of the stuff we're going to do is server client. So look at this picture. We've got a laptop. This is the client. He's going to request some information. The request is going to be sent across the internet. So this would be like a URL that I send. And then we usually have a web server. And then we usually have a tiered network, which means that the web server is not going to be the same computer that provides the application. We see that when we work with databases and things of that nature. So this is like the whole circuit you're going to make to come back to your laptop. So we have that three-way handshake. We have the connection, the three-way handshake connection, and then we always have a request. And the request is going to be a URL or URI that tells it what document you want, and then it's going to send a document back. And everything on the internet works like that, all of the client server applications. So whether you're using a SQL database, whether you're using a web server, whether you're using an FTP server, you're always going to have this little circuit going on. It's good to know kind of this circuit because you can start to visualize what needs to be protected, right? You need to know how it works in order to protect it. All right. No data in the LAN to WAN domain should ever be transmitted in clear text. So anything that leaves your LAN should not be clear text. I don't know. I mean, are you going to encrypt all of the web traffic for people looking up their email or whatever? I don't know. So the general rule is, you know, especially if you're like in a network that's not very permissive, that is kind of paranoid, you want to encrypt everything. You could have the stuff on your LAN in clear text, but you definitely don't want it crossing over the internet in clear text. Remember, your data is secure as just as much as your administrator is trustworthy. Do you trust everybody that works at Suddenlink? Well, I don't know them, so probably not. So it probably is going to have to be encrypted and not sent in clear text when it leaves your network. When using encryption, select the algorithm based on your needs. Don't just select the largest key. Why do you think that is? Why not just implement the most difficult, complicated encryption you can find? Any idea? Number one,
Say that one more time. I'm
why
trying
wouldn't
to
you want
think.
to pick like the super duper hardest encryption, longest key encryption you can find?
Then it would take a long time to unencrypt.
Mm-hmm. So it's going to take up resources, right? Remember, with all of these controls comes balance. We don't want to lock it down so tight nobody can use it, but we don't want to be at the other end of the spectrum either where everything's just in clear text. So judge, you know, one of the things that the government does is they say, how long is this information going to be sensitive? Right? If the information is not going to be sensitive after a year, you could probably use a weaker encryption. But if that needs to stay secret for 20 years, you probably need to use a real strong encryption. So think about the problem, think about the context of what you're doing. The other thing, the second probably thing that you need to worry about is interoperability. So if you pick some strange encryption algorithm, not everybody might support it. So those are some things to think about. What it wants you to do is not just jump and turn on some encryption. It wants you to think about it. Assume the attacker can intercept and examine any network messages. And I would also say assume the attacker can intercept, examine it forever. So if you're transmitting something that needs to stay secure for years, Think of a social security number. Think of a medical record. Those don't become less secret over time. Maybe after you die, your social security number might be okay to let loose. But even if after you die, they could still use social security number to do damage to people. Um, so um, they can sit there for 20 years and try to break your encryption. Depends on what they want and who they are. It might not take them 20 years. So always assume that the attacker is going to be able to intercept it, examine it, and just play around with it at their home for years if they wanted to. Just have that mindset. These are the devices that we need to talk about and access controls we need to talk about in the LAN to WAN domain. You know what a router is, right? That's what's nice about our program is we're real heavy into Cisco. So you've had networking classes. Imagine if you were taking this class and you were from the School of Business, because people from the School of Business have to take this class because they're going to be auditors. Imagine if you didn't know what a router was, right? So this stuff is pretty easy for us because we've been through the security classes. We have a background in technology. This stuff makes sense to us. Right? So a firewall, right? So we can selectively let traffic into the network. A proxy server. Remember, a proxy server protects your computer. We never directly contact somebody on the internet. That's what a proxy server does. We call a bastion host. Demilitarized zone. Remember, that's a section of your network where we're going to allow people from the outside, from the internet, to contact. On our inside of our network, our LAN, we're not going to allow any access to people on the internet. But in this DMZ, we have applications, we have servers that people from the internet need to be able to access. So we have that DMZ. A honeypot, we haven't really talked about. A honeypot is, when you think of honeypot, think of honey. It's sticky. Think of quicksand. You get stuck in it.
Isn't that something you put like outside your firewall so then they attack that thinking that they attack your internal system or something like that?
Yeah. Yeah. Well, when I see honeypot
Like
now,
you
I think I'm one of those women, with the sleeping with the senator in California. It's the same kind of thing. It's a trap, okay?
Yep, and it
Um,
grabs like your IP and all that sort of fun stuff.
I can't. I think her name was Bang Bang or something. I can't remember. It's this Chinese girl. Anyway, a honeypot is a piece of software I run on a computer, and they've got one that is popular. Let me write with a pen. It's called Honey D. Like that. That's the project. It's open source. It's based on Linux, I believe. And what you do is you download it, and then after you set it up, it's like, hey, what do you want me to impersonate? So you can impersonate a Windows box, you can impersonate a Linux box, and then it says, well, what do you want to name this box? And you name it like credit card processing server. Something that's real tantalizing, right? to the hacker. So this box doesn't really do anything on your network. It performs, you don't share it with another purpose. The only job of the honey pot is to sit there and wait for somebody to connect. As soon as somebody connects to it, it should alert you. It should page you. You need to have that live interaction with it. It does no good for you to get a message the next day that somebody contacted the honeypot. As soon as somebody hits the honeypot, you should get a message. What the honeypot is going to attempt to do is slow the attacker down. Okay? The honeypot is not to be used in court, right? You're never going to get that admitted in court. Oh, entrapment. Oh, I never would have done it if it wasn't named credit card server. Don't use honeypots in court, right? is to slow the attacker down and give you a chance to block his access, to shut down his attack. Does that make sense? So it does all kinds of stuff, all kinds of tricks, right? So one of the things it'll do is it'll let them connect and it'll keep dropping their connection. So it kind of mimics having a slow internet connection. So like, man, every time I get in this box, I got to re-authenticate, type in my password again because it keeps dropping my connection. The other thing it'll do is it'll respond really slowly, right? So if you get the web interface on it and you're trying to pull up a website, the web page will load really, really slow. Like kind of like it'll mimic an overloaded system. So the whole time they're there fighting with this stupid honeypot, trying to get it to give up information, you're responding, right? You have like an incident response where you're like, I'm going to shut down that port. I'm going to block his IP at the firewall, those types of things. Does that make sense? So don't think of a honeypot as I'm gathering evidence against somebody. Like I said, they never take that in court. So it's more for just slowing people down. Your internet service provider, we need to think about that. How reliable is your internet service provider? Can you take legal action against an ISP if their internet service is down for 3 days and you lose $1 million worth of sales? I don't know. Somebody tried to search when we had America Online back, in the 90s when it had dial-up. They were down for like 2 weeks. Nobody could use the internet for 2 weeks if you had an America Online account. So all these people got together in Virginia and said, we're going to sue them, class action lawsuit, for a half a month's worth of internet fees, right? They were paying $20 a month. So they wanted $10 back because they were down 2 weeks out of the month. What the judge said was, you're not buying 24/7 connection to the internet. You're buying a service. And you're buying a particularly crappy service, right? So you're paying for the service. Whatever the service is, that's what you're paying for. You're not paying for internet connection that's always on. So you probably won't have any traction in court if you go and try to say, well, we lost all. So, it's Black Friday. You're doing all of this business on your website, and then your website goes down because your ISP's down. So you lose all of the sales from Black Friday because of your ISP. Like I said, you're not going to be able to go to court and sue those people. Now, if you have something called a service level agreement or SLA, you might have some legal grounds to sue them. So if you're a business, you typically get a service level agreement from an ISP that says, we're going to be up 99% of the time. And if we're not, here's your remedy. Or it's an agreement, a beforehand agreement about this is our service. This is what we're going to provide to you. And if we don't, here's the breach of contract. This is what we're going to give you, or, what you're going to be entitled to. All right. So we need to look at that and make sure that our ISP is working. I talked to the people at Vidant. And Vidant, think about their internet connection, right? What if their internet connection goes down? So when I talked to them, they said they have a connection with Suddenlink, and then they also have a connection with CenturyLink, I think, or whatever CenturyLink is now. I don't know if they changed their name again, if it's Sprint or whatever. So they have a double ISP. They've got 2 different routes to the internet in case one of them goes down. And one of them could go down because somebody's digging and cuts a cable. You just don't know, right? So we want to have 2 paths to the internet typically, especially on Black Friday. Intrusion detection system. Intrusion detection system is kind of like a honeypot. It's not going to try to slow them down. It's going to be transparent. And what it's going to do is page you when something happens on the network, or it's going to log something into a security help desk, a SOC, a security operations center. The intrusion prevention system is going to actually take action. So the difference between detection system, prevention system, the IPS is actually going to cut their cable, their port. They're going to turn off their port. So it's going to block the attack. Whereas the intrusion detection system is more passive. It'll tell me it's going on, but it won't take any actions to stop the attack. The problem with intrusion prevention systems is if somebody figures out you have one, they can use it to perform a denial of service attack on you. They can purposefully trigger that IPS and block your internet connection. Data loss, leak security appliance. If you're in the Palo Alto class, you saw that we have file filtering, where it looks for files that go out of your network. And if it sees a social security number in it, a number that's formatted like a social security number, if it sees a number in a document that is formatted like a credit card number, it's going to block that document from being transmitted. So we have DLP, the data loss prevention. We have an appliance that does that. And if, like I said, that Palo Alto class, we saw that, it looks for patterns like that, and then it blocks the file. It stops the information from leaving your network. The web content filtering device, that's just going to keep our users safe. It's going to stop us from having liability because of stuff that our end users do. Okay. Case in point, everybody at the company's deciding to look at pornography on their computer during work hours. How can that turn into a bad thing where you're liable for something? Any ideas? I mean, they're just looking at porn. Why is that bad for the company? What could happen is you might have a female in the company and she feels like that's like a hostile work environment. And if you don't have web content filtering and everybody's looking at pornography at work, you could be taken to court and sued for, sexual discrimination or, like I said, hostile work environment. So we have a responsibility to protect our workers from stuff like that. And then traffic monitoring device, just to shape our traffic, to figure out who's using up all our bandwidth, who is looking at Netflix and shouldn't be, that we need to shut down. Think of these devices and access controls that we can use. We're really getting more into logical access control now than physical. The user domain and the workstation domain, we're putting locks on stuff. We're making sure people don't write stuff down. Those types of things. Now we're getting into logical, where we're pushing buttons on a keyboard to control risk. Remember, the internet is called a WAN. So when you see this LAN to WAN devices, whenever they say WAN, they're talking about the internet. And then we have our DMZ, and then we have our LAN. Okay, so let me draw a little thing here. Remember, if you remember from the Palo Alto class, traffic should be able to selectively pass this way. Maybe only port 80. We should allow traffic this way from our internal to the DMZ. We should not allow connections from the DMZ to the LAN. So we'll put a little cross that. We shouldn't allow traffic back. We should allow traffic from our LAN to the internet so we can get information. We should not allow traffic from the internet to our LAN. That's a no. So that's what the DMZ is. I'm selectively saying what can go where. And the DMZ is going to be a part where people from the outside have a legitimate use for something that's in this DMZ. So we only put computers in there that we're willing to sacrifice if they get hacked. So I probably wouldn't put a server with social security numbers in the DMZ or something like that. All right. We want to protect it. And these servers are going to be hardened probably more than the servers on the LAN because they're going to be under constant attack. And as soon as you connect to the internet, it's going to be attacked. I think I was reading the forensics book, and it says once you put a computer on a network, you get an average, any internet device gets an average of like 50 attacks a day. Right? Once you set up your Palo Alto firewall, you'll start seeing it. You'll see all these different countries. And I'm like, why am I communicating with South Africa? And it's just people running scans, trying to script kiddies running scans, trying to look at your network and figure out what's on your network. So in this model here, we had one firewall with multiple ports. We could also have a layered kind of thing where we have multiple firewalls. So we could have the internet, and then there's selective access to the DMZ, but there's no access from the internet all the way back to the LAN. Typically, we don't use multiple firewalls. We could. Typically, we have this model where we have a firewall with multiple ports. It all depends on what you want to do. Some people like this model because what they can do is make this firewall maybe Cisco. And then you can make a Palo Alto firewall here. Why do you think you would want to use two different brands of firewalls in your setup? Any ideas? Maybe job security, right? Because you have to find an administrator that knows Cisco and Palo Alto. No, I'm just kidding. This is called diversity of defense. It's part of that the defense in depth where I'm having multiple firewalls, but also it's going to be diverse. So if there is a vulnerability, think about SolarWinds. It's more unlikely that that vulnerability will be present in both of these brands of firewalls. If both of these were Cisco and I found a vulnerability in Cisco firewalls, I'd be able to get through both of them. But if I'm using two different brands, I've got to hack the Cisco one first, and then I get back here and I'm like, oh man, there's that Palo Alto firewall back here. Well, let me try to find a different attack, a different vulnerability for the Palo Alto one. So that's really good to be able to
Slows them down.
The thing is, it makes the network more complex. So you have to know more. I mean, you always want to strive for simplicity in your network so that it's not difficult to administer because you're going to make mistakes. But think about it. I mean, this could be, more high security than just having a Cisco one here. If you have one firewall here, once they get through that one firewall, they have everything, right? If I did this setup over here, they've got to become experts in both. Other things we see like that is we'll have a Windows server back here. And typically, one of the stages of an attack is they're going to try to cover their tracks. So they try to delete your logs. So what I'll do is I'll have a Linux on the back end here also, running syslog. And I'll have the Windows box shipping all of the records to the Linux box as the logs are created. That way, if this Windows box gets hacked, I have a witness that they're going to have to break into also. If I didn't ship those logs off and they got control of this Windows system. They could delete the logs. I would never figure out what they were doing. Now they've got to break into a Linux system and erase the syslog server from the Linux system. Forces them to become experts in two different operating systems.
And then what if you had the Linux upload the syslog to a
To the
server?
cloud. Yeah.
Yeah.
Yeah, I know. So that's what they talk about layered security. They talk about defense in depth. They talk about diversity of defense. All of those principles. Think of how more secure you're going to be when you do stuff like that. And it's not something that you would probably normally think about. So that's why you take the class, right? You would learn eventually from experience that it's better to have two firewalls. You know, you'll get burned a bunch of times. You'll get hacked into a bunch of times, and you're like, well, shoot, since they always get one vulnerability, since they get the SolarWinds vulnerability and they're able to go through everything, why don't I use a different brand on the inside? And it's something you'll learn, right? But you're kind of taking a shortcut by taking this class, right? So that you don't have to make all these mistakes. You kind of know this idea in your head, how things should be set up. Remember, we want to be capturing our network traffic and determining how people are using it. And because we need to know that, right? If I don't know what's going over my network, I can't guarantee that I'm gonna have quality or access at all. I can't guarantee service if I don't know what's on my network. I mean, people look at that as, oh, that's bad. You're snooping in all of your end users. I don't want to be the computer place. I don't care what they're doing. I just want to make sure they're not destroying my quality of service. You know, taking up all my bandwidth watching Netflix from their office all day. We can monitor the network using devices. Or we can use non-device based monitoring. Non-device based monitoring, which would mean like I have a snort box and I have one of the mirrors ported. One of the ports mirrored. So I'm using span or something like that. I'm eavesdropping on one of the ports on my switch with a desktop computer. That would be non-device based. And then network device base would be I buy something like a Barracuda box or what is that other brand? I think it's Barricade or something like that, where it's a piece of hardware just devoted just to monitoring the network. It's always going to be better to get the device because it's going to be faster and it's specifically designed to do what you're getting it to do. Thing is, it's expensive. This non-device based, I can set up a cheap PC somewhere, mirror it, and run open source Snort or something on there. So there's different ways to do it. It all depends on how much money you have. Right? It's nice to work at a place that has unlimited amount of money, like the government. But in actuality, you're not always going to have that. Remember what we've been talking about every chapter since like chapter 3, change management. So, you know, when we go to these chapters, it's typically nothing new. It's just reapplying the same stuff we've learned in the previous chapter. Right? So here's a picture of what change management looks like. You've got a requester. So this is the system, the security administrator for the company. And he submits a setting or a rule change. So he wants to add a rule or subtract a rule from the firewall. Hey, my end users need port what is it? 143, I think, is SQL. They're starting to use SQL. They need 143 open now. Well, the security administrator can't just go do that on a firewall, right? Without talking to anybody. He's got to go submit it to this configuration control board. It's going to look at it and say, is this something we are worth risking opening up another port in a firewall? So you might have a bunch of people on this board, and they're mostly going to be concerned about risk, right? Is this something that we should be doing? And then the implementers are going to receive and make the approved change. They're going to validate the current configuration against the baseline, validate the configuration in a test environment before they actually put it in production. They're going to create a new baseline after they apply the changes and they've been accepted. And then they're going to validate it to make sure it's working correctly.
Would they also check for like protections against attacks like SQL injection, code
That would
injection?
probably be that configuration control board. They're probably going to look at that kind of stuff too. They're going to do research. They call those threat hunters, people
Uh-huh.
that actually go out and look for stuff. Right. That's like tier two of the Security Operations Center. Um, remember, uh, separation of duties. So the person that is on a configuration control board should not be the implementer. It should be two separate people. It stops people from bypassing controls. So
It's like
these are different.
having
Go
multiple
ahead.
keys. It's like having multiple keys to launch a nuclear missile or something.
Right. Exactly right. So it's good that you thought about that when you thought about um, what did I just say? My brain's not working for some reason. The having multiple persons having to do something, right? Um, it's called dual control, or that kind of thing. But yeah, you're right. So you have the requester, which is one person. The configuration control board's a different person. An implementer should be a different person. It's not always that way, but that's the best practice, is to have them separate. So that's, the person that's requesting it's not approving the changes. I mean, why even have it if that's the case? The book mentions FCATs. So they have all these different managements that you should have in place. Fault management should detect, isolate, notify, and correct faults encountered in the network. So if the network is something wrong with it, something should go off and tell me. Okay? Um, I'll give you an example. We had a mail server at Pitt, and the mail server was set up with RAID. If you're familiar with RAID, what it is it's a double copy of everything. Okay, so we'll just say mirroring. We'll say RAID 1, where we have two copies of everything, right? Um, so they had their mail server raided, and inside the server room, one of the hard drives went bad in their server. The server was not set up to notify anybody when it happened. So basically, all you had was a light that was blinking on the drive to tell you that it was offline. There was no direct communication between the server system and the administrator. It was just a blinking light in the server room. And the only way you could have caught it is if you walk by and you're like, oh, that light shouldn't be blinking, right? But typically, nobody goes in the server room. It's a security problem if people are going in and out of security room, server room all the time. So fault management would have told you one of the drives is down. So basically, what happened at the school was they lost another drive. When they lost the second one, the system was down. Um, and let me see if I can remember. The mail administrator wasn't too sure about what he was doing, and he was using restore points on the server instead of doing backups. And if you know anything about restore points, it's not really a backup. It's just a restore point of the registry and stuff like that, configuration changes. Restore points don't typically do like a bulk data backup or anything like that.
So when
So
that drive died, they lost everything.
yep, they had to call somebody from HP to come in and repair
Get
the
the data
drive.
off the drive. Yep.
Well, it was like a controller on the drive or one of the boards on the drive. So they just did that. They were able to get their data back. Right?
Oh,
Typically, you can get some of your data back. Typically, the entire drive isn't shredded. You know,
yep.
typically you replace one of the boards on a drive or something like that, and you can buy them. If you look on the internet, you can um, buy replacement boards for hard drives, and then you just swap it out, and then the hard drive works again.
And it's also like not like the data's lost completely because you can still read off the disk, right?
Right. Or you can transfer the disk to something that can read it. It just costs
Yep.
money, right? It just costs money. Um, Typically, the entire magnetic platter is not going to be destroyed. They might have a bad sector. Well, we can work around a bad sector. We just want the rest of the files back. That would be an example of fault management where it would tell you when something happened. You would know. It wouldn't be a surprise to you. Configuration management, we just talked about. Accounting management, you collect usage information of network resources. Typically, you see this in big companies. When you get the IT to come out and fix your computer, you usually have a chargeback, right? So if I'm working in the warranty department and I call from help from the IT department, the IT department bills the warranty department for my time. If there's no cost to calling you, they're going to call you all the time. You'll be there all the time. So there has to be some kind of reckoning where they're like, this is costing something for me to forget my password every day, right? If it costs your department $10 every time you forget your password, you're not going to keep forgetting your password. So it kind of cements in that accountability to make sure that um, people aren't wastefully using resources. Also, think of printing. You don't have a blank check to do printing. Typically, the IT department sends your company, your department inside the company a bill for printing every month. That would be accounting management. Performance management, monitor various aspects of performance so that all overall performance can be maintained at a defined level. That's that service level agreement, right? We're telling you as an IT department, the warranty department, you're going to get at least 10 megabits per second internet connection. So I'm going to monitor the performance of the network. So the network can still work and move really slow. So we need to manage that also. And then security management, that is setting up classification systems, um, setting up access control. So we have to have management over that. So the F is fault management, C is configuration management, accounting is A, performance management is P, and security management is F. So F caps is just to help you remind you that that's the things you need to have in place. Network access control, also called network admission control. So two different, the same acronym. Cisco calls it network admission control. Everybody else calls it network access control. When you plug your computer into the network, it's going to check to see if you have antivirus installed. That's the first check. Then it's going to look and see if your firewall's turned on. Then it's going to look and see if your patches are up to date on your operating system. Then it's going to look and see what department you belong to. It's going to look at your identity to see if you're actually allowed on the network. And then I can set up custom attributes to check. If any of these tests fail, it turns off your port. You're not allowed access to the network. So what they'll typically call this, Microsoft calls it an HRA, a health registration authority on the network. So one of the Windows servers is going to be this health registration authority. It's going to be responsible for checking your computer. Check it to make sure this is up to date, that's up to date.
does the anti-malware protection consider Windows Defender, or is it looking for like specific other ones like Malwarebytes?
You define that as an administrator, and it's pluggable. So if I download Kaspersky and I want to use that for my particular computers, there's a plugin for the Microsoft Health Registration Authority that allows it to speak with the client. Huh?
Oh,
So each one of these different brands or vendors is going to have a plugin for Microsoft Server to tell it how to check. This is built into Windows. It already knows how to check because it's a Microsoft product. You're running Windows OS. It knows how to check that already. Like I said, you can set up custom things. And also, should they be plugging into our network? It's going to pop up and ask us using 8021X. It's a protocol. It's called not port security, but port. I can't remember what it's called now. But what it does is it turns off your Ethernet port on your switch until you send a special frame with your authentication information on it. And once you do that, it'll turn on the port on your switch. And again, the standard is 802.1x, and it's an authentication protocol. So all of that's going to be built into here so that all of this is turned on. Oh yeah, well, you also have to give us your username or we're not going to let you on the network. I mean, you won't be able to pass any frames at all till you authenticate. The only kind of frames you'll be able to pass is 802.1x frames for that particular protocol, but you won't be able to surf the internet or anything. All of this stuff takes a lot of infrastructure and server setup. It's not something easy you could just turn on, right? It does come built into Windows. So if you have a license for Windows Server, you have this built into your server already. It doesn't cost anything extra, but you need to have done all of the infrastructure work and all of the background work to be able to turn it on. I used to turn it on and test it when I was teaching the Windows Server classes a few years back. And that's how I learned how to use it, teaching a Windows class. We don't use it on our network in the information technology department. I think the school only uses port security, which is like the Cisco stuff, where if your MAC address doesn't match, then it doesn't let you connect. But remember, you can always spoof a MAC address. So, like I said, it's a balance. How much time and money are you going to spend on a security versus, whether it's actually worth it or not? Because this is quite involved setting up all the stuff. You have to set up PKI to use this also. So set up a certificate server. Back to the CIA. Remember, confidentiality. Only people that should be able to see something or have access to something has access to it. Integrity. Only people who should be able to change things are able to change it. And availability. People that are supposed to be able to access the system can access it when they need to. CIA. That's going to keep coming up over and over and over in all your security exams. Right. Maximizing availability. We're going to minimize single points of failure. We're going to use server clustering. We're going to have multiple internet connections, right? This dual homed ISP connection. Using alternate ISP connections. So we can have two wires running to the same ISP. They call that port aggregation. I think Cisco calls it ether channel. And what it does is you have two wires in case one goes bad or one of the ports goes bad. You still have a connection.
Yeah, I remember setting that up in my Cisco classes.
Mm-hmm. Because it's really important. Nobody even knows about the IT people till something goes wrong. They're not going to reward you for doing the things that you're supposed to do. All they do is they notice when things are down. So you want to keep that to a minimum, right? Remember that what we're striving for is the golden nines of availability. That's 99, It's 5 nines, 0.999% uptime. Which means you can be down 10 minutes a year, I think. That's like the standard. And this is going to help us get there. Yes, it is expensive, but you explain that to the business people. Well, with great power comes great. No, I'm just kidding. If you want to have this stuff up all the time, it's going to cost you money. The higher the availability, the more it costs. Buying 2 routers, buying 2 firewalls. When we get to the end of the Palo Alto class, we're going to talk about HA, high availability, where we can take 2 Palo Alto firewalls and link them together so that if one of the firewalls goes down, you don't even notice it. Looking at a Palo Alto right here at my desk at home, and every single one of them comes with 2 power connections. They don't give you 2 power cords, but there's 2 power connections in the back of even the 220s, the smallest firewall you can have. So you can plug it into 2 different outlets, right? So you can have on 2 different fuses in case one of the fuses blows or something, your network doesn't go down. The power cable in the back of the Palo Alto is threaded, so you can't accidentally unplug it. So you stick it in the back of the Palo Alto, and you got to twist it like 3 or 4 times, and it screws in the power connector so that somebody doesn't accidentally unplug it. So it's all about availability. Having backups. Whenever you think of doing backups, remember backup testing. It does you no good to do backups that you can't use. And then use VPNs. Remember, that's an encrypted tunnel. We'll get more into that when we go to the other domain. Here's a picture of a network that has a single point of failure. This is going to be our Cisco router or whatever. We're connected to Suddenlink. Or maybe this is our cable modem. Or whatever it is. That's a single point of failure. Equipment always goes bad eventually. Right? The transistors inside blow up or gets hit by lightning or something. Here's another example of where I have 2 different gateways. So I have 2 different routers that are connected to the same ISP. Like I said, we can also have multiple ISPs. That's what Vidant does because they have to be online. Literally, people's lives depend on it. Right? Here's the pen testing. So what you're going to do when you pay somebody to do a pen test, they are going to do reconnaissance. It's better for you to find the information on the internet. Remember, reconnaissance is just going out on the internet, on Google, and trying to find out things about your company. It's better for you to find them ahead of time and then try to get them off. You probably won't be successful getting them removed from the internet because once something's on the internet, it's always there. But at least you know it's out there so you can work around it. An example would be a bank. Some people like to walk around and take pictures of old buildings because of the architecture, right? Well, they take pictures of your bank building and they take pictures of the entire bank building and you can see where all the cameras are. It's out on the internet, right? You can call that person like, hey, can you take the pictures of our bank down because people can map out where all of our cameras are? You can do that, but it's probably not going to work. So you want to know what's out there about your company. Footprinting is they try to figure out what OSs and what softwares you're using. Sometimes that's part of reconnaissance also. They go through your job ads. So they go to your Human Resources Department website and see previous job openings. And they'll say, we require somebody with expertise in Apache web servers. And you're like, oh, they use Apache web servers. And then they're like, and then we need somebody that has expertise in Microsoft SQL. Well, they use Microsoft SQL now. So that's what footprinting is. I'm footprinting your network, figuring out what OSs you use. Scanning and enumeration is when I ping your workstation or ping your servers to find out which ones are turned on. This is real easy to detect usually. It's always a prelude to an attack. You see people port scanning your network. Somebody's looking at something. That's trying to. It's like somebody walking down the hall in your building and trying all the doors to see if one is left unlocked. They're up to no good. So if you ever see this in your Palo Alto or you get a message saying that there's a port scan going on, somebody's getting ready to attack you. Once they know what OSs you're using, once they know what computers are on, they identify a vulnerability. So they know you run Apache. They checked. You do run Apache. They ran something like, there's a Netcraft. Netcraft will let you run a scan against the server, and it'll tell you which server they're running, what version of server, and all kinds of stuff. It's called Netcraft. And then they've already scanned your network, and they're going to identify a vulnerability with Apache since they know you use Apache. Usually when they do their footprinting, they're going to figure out which version you use. Once they identify how they're going to get into your system, their plan, they make an attack plan. How are they going to deliver that exploit to your network? What's going to be the payload? So we know the exploit. What are we going to put on the system through the exploit, right? So the exploit might be a weakness in the RPC server. Well, what are we going to do? An interpreter shell? How are we going to control it after we get through that vulnerability? That's the payload. That's part of this attack planning. They're going to actually execute the attack. And then what they're going to do is tell you at the end, since this is a pen test, they're going to say, we recommend these new controls. We recommend these changes. That is the process for a pen test. Remember, we need to have this vulnerability management going on. Remember, this is a cycle. It looks like a waterfall, but it's really not. Because once we get to the bottom here, we're going to go back up to the top. It's risk management, vulnerability management. So we're going to put a policy in place, one of those controls. We're going to perform a baseline. After we define the policy, we're going to assess the true security state of the environment and determine of instances of if there's people working around that policy or working around that control. So we're going to actually test it to see if the policy is effective. We're going to identify vulnerabilities and prioritize them based on how much impact they're going to have on the company. Then we're going to mitigate the vulnerabilities. Remember, mitigate makes less severe. So we're going to put some extra controls in to mitigate the vulnerabilities. And then I'm going to maintain and monitor them. That's this cycle here. So we might make a change to the policy, goes back up to the top. We made a change to the policy. Did it make any difference? Look at the baseline again. If it closed the hole, then we just keep looking. If it didn't, then we reprioritize these vulnerabilities and work it over again. That's why you need an entire person devoted to security. That's why you need an entire department devoted to security, because this needs to be done all of the time. Remember, your IT department is going to be changing constantly, your environment. New computers, people coming on the network with new devices. So you don't even need to buy new equipment. Apple could come up with a new iPhone, and all of a sudden there's a vulnerability in your network because all of your end users bought the new iPhone. It's just catch up all the time. Remember the different types of controls we have. Preventative stops somebody from completing an attack. Detective lets me know that an attack has occurred. Corrective tries to lessen the impact once the attack succeeds. Examples of preventative controls would be a DMZ, a firewall, NAT, hiding IP addresses, intrusion prevention system, access controls, configuration change management, and encryption. All of these things stop people from weakening my privacy and my CIA. Detective, service exception auditing. So if one of your services on your server crashes, then it's going to tell somebody. Performance monitoring is going to tell me the state of the network and whether the bandwidth is okay. Packet analysis is going to be just monitoring the network with an intrusion detection system. Penetration testing, we're going to detect weaknesses in our system. Corrective is going to be once somebody carries out an attack and there's a virus crawling across our network, we're going to start putting these patches on to stop it from continuing to propagate across our network. Business continuity plans, disaster recovery plans, that is paperwork. It is administrative control, and this is the plan for doing business when the computers are down. That's what business continuity is. So our business continuity plan for a library would be we still need to do business. We need to still check out books to kids, even though the computers are down at the library. So our business continuity plan is what we're going to do is take the student's ID, take the book, the barcode on a book, and photocopy it on a photocopier. And then we can upload that data later on to the checkout system, to the circulation system in the library. That would be an example of business continuity plan. Disaster recovery plan is I have documentation. If the server catches on fire, I know exactly what server to buy. I know all the parts. I have a backup. This is how we're going to return to normal operations after a disaster. We have those two documents. We should always have those. So the best practices, and this is a best practice, but it's not always feasible. Map your proposed architecture before installing any hardware. So that would be like if you're walking into a business and there's no network. Use the several available network mapping software products to make the process easier. It'll document all your switches and all your routers. Identify all the components, data paths through the domain, all the wiring. Right? Use the map to identify single points of failure. So once you draw out this network diagram, this physical network diagram, you might want to do a logical network diagram also. Identify your single points of failure. Make sure you keep it updated. Right? It's not good if you add a whole branch onto your network and you don't have it documented. I'm going to tell you, documentation is the least favorite thing to all of my computer people. Best practices, establish a DMZ with at least 2 firewalls. Again, that is for diversity of defense. So I have 2 different systems. Implement at least 2 redundant WAN connections. Configure all DMZ servers to resist attacks from WAN users. That's called server hardening or system hardening, right? Backup and recovery plan, how we're going to do business if we lose the server. Implement frequent update procedures for operating systems. So always do patches, testing before you put patches on there. Define routing and filtering rules to restrict traffic. Again, that's on the firewall. Also, you might want to use static routes. Depends on what you're trying to do. Monitor your traffic. Have configuration controls in there. You can also use Active Directory to check those settings to make sure they're still in spec. Update network maps after changes. Use an automated tool. This is really the only way you can do this device management on your network to know whether somebody plugged something in they shouldn't have. Deploy at least 1 intrusion prevention system for each WAN connection. Remember, IPS will stop an attack. Detection system will not. Do your penetration test annually. Pay somebody to come in and try to break into your system. It doesn't help you to try to break into your own system because you don't see your own flaws. Does that make sense? What you don't know is going to hurt you. And if you hire somebody from the outside, they're going to know stuff that you don't. It's going to make your security all that stronger. And that is the end of the chapter. Let me go ahead and stop the recorder.